Hello, in this video we'll be looking at stress and strain and Young's modulus. If you were to put a material, let's say we put it under tension, you would get a tensile stress acting on it. And if we were to put the material under compression, i.e. you squeezed it, you would get a compressive stress. Okay, now what is this stress? Stress is simply the force applied divided by the cross-sectional area A. So that's force divided by area, and that there is the cross-sectional area A. Now, and it's the stress is given by that symbol there, which equals force divided by area. And what is strain? Strain is actually the extension, which is X in many syllabuses. Sometimes strain is written as E, which is extension over L. So it is the extension of it, or if you like the compression, if you're squeezing it, divided by the original length of the material. So that's what your stress and strain is. Now, you can remember before from Hooke's law, we spoke about from Hooke's law, if you get force is proportional extension. Well, very similar, because that is force and extension there, you could in fact think about Hooke's law as a graph of stress against strain. And also within the limit of proportionality here, you'd find that Hooke's law says that stress, which is proportional to strain. So this is Hooke's law again. Okay. So therefore, we can write that as stress is proportional to strain within the elastic limit. Okay. Now we'll look at Young's modulus. So Young's modulus is given by the ratios of stress over strains for a certain material. So this is Young's modulus, and that is called E, is equal to, for a certain material, the stress divided by the strain. So for copper, we'll have a particular value of Young's modulus, steel will have a particular value for Young's modulus. So that's stress over strain, which equals force over area, all divided by the extension divided by the original length. So each material will have a different value for Young's modulus, and it would apply equal to compressive and tensile forces. So, in fact, if you were to plot a graph, let's plot a graph for a particular material, we were to plot a graph of stress against strain. So remember, stress is that and strain is that. If we were to plot a graph, we'd find that the gradient, of course, here, so we found out the gradient of the graph of stress against strain graph, the gradient would give us Young's modulus E, and the area under the graph would in fact give you the energy, the strain energy per unit volume. So that is the strain energy per unit volume stored in the material.